Thank you, June. I'm going to talk about which roadway features are problematic to older adults. This presentation is part of a big project which we just completed for the Michigan Department of Transportation. We had several tasks that we performed, but I'm not going to talk about all of them. I will just focus on crash analysis and what are the roadway design issues that we found that might indicate that they could be posing some issues with older drivers. And by older drivers here, I mean age 65 and above. Now, what was the motivation of this study? I'm not sure if all of you are familiar with this handbook, but in 2014, in fact, before that, but the current version is 2014 handbook for designing roadways for the aging population, which is produced by the Federal Highway Administration, has guidelines on what roadway features, what things should a roadway designer think about when they are designing a roadway with the aging population in mind. They got different roadway features, different recommendations for different roadway features, intersection elements, how you should design intersection in such a way that older drivers will be accommodated well. Interchanges, roadway segments, construction work zones, highway rail grade crossing. So that handbook is out there. Now, the Michigan Department of Transportation thought about their current design standards, and the question was, are these Michigan roadway design standards consistent with what the handbook is recommending? So there was a need of identifying roadway design features or identifying standards in the Michigan roadway design manual that are not consistent with the handbook so that we can make those recommendations. But how do we do that? We had to look at different things. One was looking at crash data. What do crash data say? Do they indicate areas where older adults might be having issues? And are those areas or are those roadway features the same as the ones that are recommended in the handbook? And are MDOT standards for those roadway design features consistent with what is in the recommendations? So we had to look at crash data. So we had these two objectives: analyzing the association of older adult crashes with roadway features and providing recommendations and developing roadway design guidance. Now, I'm not going to talk about the recommendations we made, but I will just end my presentation on what we found from the crash data. And the final report for this project is actually online, so if you are interested with more details on what are the specific recommendations we made for Michigan Department of Transportation, you can access that. But among the other tasks that we did for this study was a survey of drivers in Michigan. We wanted to ask them and see what do they consider to be an issue for them and compare older adults versus young drivers and try to see what could be issues that are specific to older drivers. But I'm not going to present the survey results. In fact, there is a poster. One of my students has a poster out there which documents everything about the survey. So take a time to check that poster. So overview of crash data analysis, we used 5-year crash data 2010, 2014. We focused on identifying roadway features that are relatively problematic to older adults, 65 years and above. And I'm going to talk about that third bullet in a moment. We analyzed single vehicle crashes separate from multi-vehicle crashes. And in cases where we found an indication that there could be a problem which is specific to older adults, we did a detailed analysis of the crash reports, UD10s, to try to understand the exact conditions on the roadway and the geometrics of that location. But before I go into the detailed analysis, I'm going to talk about the general crash data analysis, because we did a general crash data analysis basically trying to see if you look at crashes that involve older adults, what are the trends in Michigan. This chart is showing the trends of the percentage of older adults as a percent of the population in Michigan. That is a blue line, and that's from 2005 to 2014. And the red one is showing the percentage of crashes that involve an older adult in Michigan for those years. Now, obviously, you can see something happened. The red one was lower than the blue, but now the red one is higher. So something might be wrong, maybe. Who knows? Then we looked at, for example, if you look at the overall crashes that involve an older adult, where do they occur the most? So the location of the crash, interchange, intersection, or mid-blocks. Most crashes occur at intersections. And if you were to look at the ones that involve an older adult, there are even more at intersections compared to those that do not involve an older adult. So that could be an indication that intersections are more problematic to older adults than the other driving population. So just a quick summary of findings from general crash data analysis. When we looked at roadway characteristics, we saw that older drivers were more likely to have higher proportion of crashes in multi-lane roadways compared to drivers who are 64 or younger. Older drivers have higher proportion of crashes in roads with no access control compared to the other age group. And on environmental characteristics, we found that higher proportion of 65 years and older related crashes occur in daylight. When we did a survey, I'm just gonna give you one result from the survey. When we did the survey, we found that many older adults avoid driving during the night. So I think it makes sense that most of the crashes will be occurring during the day, because most of them are driving during the day, not during the night, compared to the other age group. 64 years and younger drivers were more likely to be intoxicated compared to the older adults. And crashes that involved the 65 years and older, most of them were turning, especially making a left turn, compared to the other age group. Now, I'm going to go now into the detailed crash analysis, but I need to clarify one thing here. We focused on 2 vehicle crashes involving one 65 years and older driver and one 64-year and less driver. Why? Here's the reason. If you have a lot of crashes occurring at a given location and they are involving a specific group of drivers, there could be multiple explanations of why that is happening. One, maybe that area is problematic to that age group. That could be a reason. But the other reason could be maybe there are so many of those drivers of that group who are on that area compared to other drivers. So the exposure is very, very important. You have to know how many older adults are driving on a specific area before you try to pinpoint whether they have a problem there or they don't. Now, how do we know how many drivers or the adults were there when crashes occurred. It's very difficult. One way is stand on the roadway, observe every driver, count them, and then count all crashes. And then you can say, yeah, I know I had this many older adults and I had this many younger drivers. That is kind of impossible. So we decided what we're going to do is we're going to take crashes that involved two types of drivers. One, an older adult, another one, a young driver. Now, if everything was equal, what are we expecting? When you look at all those crashes, drivers who commit hazardous action are supposed to be 50-50. If that is not the case, then that's an indication that there could be an issue. So the results that I'm going to present are basically showing locations where, looking at crashes that involved only two drivers, a young driver and an older driver, and we are looking at the percentage of drivers who were responsible for the crash, because that could be an indication that they have an issue with that area. Otherwise, it should be 50-50. So we looked at different roadway design features, and we have intersection. We looked at several design elements. One is intersection skewness, left-hand offset, raised medians at intersections. Mid-block, we looked at driveways away from intersection, median crossovers, transition areas, curved segments, parking areas along the roadside, auxiliary passing lanes, and for interchanges, we looked at the entrance and the exit. So I'm going to present a few results from what we looked at. This one is showing drivers' crash responsibility at different roadway locations. Again, if you were to look at the interchanges, you can see it is 51/49. So the orange is young drivers and the blue is older drivers throughout my presentation. But when you look at intersections, you start seeing a huge difference, that 54% of older drivers are responsible for a crash at intersections compared to the other age group. And for mid-block, it's about the same. How about areas? If you look at rural versus urban, again, you can see that the rural versus urban, drivers who committed hazardous actions at intersections, there is a difference, not big difference, of course, between rural and urban intersections, 56/44 and 43/47. But when you look at mid-blocks, you find that in rural area, it is 50-50%, and in urban area, you have higher percentage of all older drivers committing a hazardous action. Now, we wanted to know for intersections what type of crashes that older drivers who commit hazardous actions are involved in. What we found was that angle, rear end, and side swipe, same direction type of crashes have more older adults involved in those crashes, and they are the ones who commit the hazardous action, which means those type of crashes or any feature that leads into those types of crashes could be problematic to older adults. Drivers who committed hazardous actions at intersection by type of control, signal versus stop control intersections. When we looked at this, we found that at signalized intersections, the distribution is different, but not that different as the stop control intersections. You have more older adults committing hazardous actions at stop controlled intersections. I think that is probably kind of easy to explain, or at least we can suspect something there, that when you have traffic signals, as long as every driver is protected. For example, you have left turn that is protected, it's not going to be a problem to an older adult. But once you have something, you have a control where someone is required to make a quick decision on what to do, that could be a difference maker between older and young. So when we looked at drivers who committed hazardous actions at signal controlled intersections and at the stop controlled intersections, what we found that drivers by movement, this is by movement, when someone is making a turn, all the adults are more responsible for those types of crashes, which means that any intersection feature that is associated with turning is important when someone is designing a roadway with the aging population in mind. Look at going straight ahead. The young drivers are more responsible for those type of crashes than the old adult. And similar pattern was observed at the stop-controlled intersections. So we looked at what hazardous action was actually committed by those drivers, older adults. And we have the stop-controlled intersection and the signal-controlled intersection. What we found was that turning left was the main movement, and the main hazardous action was failing to yield. And that is for older adults. Now we started looking at the specific design features. So intersection is skew. The FHWA guideline, which I talked about, the 2014 FHWA guideline, states that intersection skew, the minimum should be 75 degrees. MDOT says minimum is 60, desirable is 75. So we decided to look at intersections and figure out whether intersection skew could be an issue. So we took stop-controlled intersections and signal-controlled intersections. We have intersections where the skewness angle is between 60 and 75, and we have intersections where skewness angle is greater than 75 to 90. And as you can see, the proportion of older adults who committed hazardous action at intersections with sharp angle is higher, and it goes down when you have an angle of 75 to 90. If you look at the signalized intersection, you see the same pattern. However, there is no huge difference between the skewness, which could be suggesting that signals are one of the solutions for skewed intersections. Again, because you will be controlling all the movements in a simple way. So we started looking at, for example, what specifically was happening. So we took one crash report, and this was an older adult. As you can see, this is a skewed intersection. The older adult was moving from that side, and they're trying to access a business here. So the way they made this turn is kind of interesting. Instead of going that way and then accessing the business, they just decided to go because the business is right there, so I'll just go. But that wouldn't be the case if the skewness wasn't that sharp. Now, raised medians or channelization, these are important for not just older drivers, but I think for everyone. But they could be more beneficial for older adults. And we looked at these. So we looked at roadways which have, actually we looked at all state trunk lines. These are 285 intersections that we looked at. We had 25 intersections that had raised medians, and others did not have raised medians. So we decided to compare crash responsibility for those locations with median and those without median. Now you can see the difference when you have no median, raised median, to be specific, older adults are responsible 59% of the time. But when you have raised median, they are responsible for just 52% of the time. So that's an indication that where raised median could be something of important to look at. Now, this is an example of a crash that could be prevented by a raised median. This was an older adult. It's an actual crash report, and this is an actual drawing by the police. So this older adult was moving in this way, and they sideswiped the opposing vehicle. And what if there was a raised median here? Maybe that wouldn't have happened. The other thing that we looked at was offset turn lanes. Now, this is the case when someone is at an intersection and maybe they're making a permitted left turn, and one vehicle is, you are trying to make this left turn, and you are stopped here. You're supposed to be looking for vehicles that are coming through, and sometimes you may not be able to see them if you are in the same line as the opposing left turners. So the solution is offsetting the left turning lane so that if you are making a left, then you're going to be here. So you have enough space to see what is happening on the opposing direction, and you can make a safe turn when you decide to do so. So we decided to look at these kinds of roadway design features, and we picked 286 state trunk lines, and we had only 6 intersections which had offset turn lane. And what we found was that when there is no offset, 58% of the time, an older adult is responsible for a crash, but only 55% is responsible when there is an offset. This is again another example of what I was explaining. If you are stopped here and there is another vehicle, say, in this direction, and you're trying to make a permitted left turn here, you may not see the through movement, the through moving vehicle in the opposing direction. But if you have an offset left turn lane, then it could be easier for the driver to see what is going on in the opposing direction. Intersection lighting is another design feature that is important. So when we looked at driver who committed hazardous action during daylight, dark lighted, dark unlighted, what we found was that when it is dark unlighted, you have more older adults committing hazardous action. When you look at 2 vehicles involving 1 young, 1 older adult. Mid-block related crashes, we looked at which location of a mid-block where we have a lot of older adult crashes. What we found was that older related crashes are more when you have a non-freeway curved roadway segment. So, and of course we have the parking area along the roadside. So we decided to look at single vehicle crashes at curved segments which involved an older adult. So we wanted to see what are the environmental conditions when the crash occurred. So we have the distribution by environmental condition, and what we found was that about 57% of this type of crash occurred when the roadway was icy or snowy. And what happened was basically these crashes are coded as speeding too fast. So speeding too fast was basically occurring when the roadway was icy or snowy for 64 years and older younger drivers. Okay. The other thing that we looked at was when you have a 2-lane roadway, undivided roadway, what is the use, or what is going to be the advantage of an auxiliary passing lane? So when we looked at roadways where there is no auxiliary passing lane, we found that 50% of the older adults had committed hazardous action, but where we have auxiliary passing lane, only 47 committed in hazardous action. For the sake of the time, I'm going to go into the summary. So, from the crash analysis, what we found was that intersections might be more problematic to older adults. Non-freeway curved segments and parking areas along roadsides and interchange areas are also problematic to all the adults, and the specific type of crash that we saw there where all the adults are committing hazardous action is angle, head-on, left turn, and side swipe, same direction. Stop control intersections are associated with higher percentage of older drivers who committed hazardous action compared to the signalized intersections. Turning movements, an issue to all the adults. So any design feature that is going to help an older driver make a turn safely is very, very important. Intersection skewness is something that is very, very important. But again, as we saw that, is that when you have a signal, you might reduce the impact of intersection skewness. But presence of raised median and having offset left turn lane might help in reducing crashes that involve all the adults. Thank you.